Namaste. Welcome to Indian Knowledge Systems Primer Course for Children offered by Anaadi Foundation. In this Bharatiya Ganita lecture, we will look at square roots. Square roots is one of the 8 arithmetic operations which are found in the ancient Indian mathematical texts. The word parikarma means arithmetic operation and ashtaka means a group of 8. Put together, these are called parikarmashtakam. So here are the 8 operations. The first is sankalanam or addition. The second is vyavakalanam or subtraction. Third is gunanam or multiplication. Fourth is chhedanam or division. Fifth is varga or squaring. Sixth is varga moola or square root. Seventh is ghana or cubing. And eighth is ghana moola or finding cube roots. The square root of a number a is answer to the question what number when squared results in a. The symbol for square root prevalent in mathematics is the square root sign, and the square root of a number a is usually written as square root a. In ancient Indian mathematics, square root has been termed as vargamoola, kritimoola, dvigatamoola and karani. The clear technique for computing a square root has been given by Aryabhata in his Aryabhatiya in 499 CE. Bhaskaracharya too, another prominent mathematician, in his Leelavati has also explained this technique in detail. So too have various other Indian mathematicians who have brought this out in different mathematical texts. We shall study a verse given by Aryabhata. In this verse, we shall see Aryabhata's square root technique. Let us listen to the verse now.
Bhagam hareta vargat nityam dvigунेन vargamūलेन vargat varge shuddhe labdham sthanantare moolam.
The import of this verse now we will understand by looking at an example. Aryabhata says that we must classify the digits of a number into vargasthana and avargasthana. So let us say we want to find the square root of a given number. The decimal places which are multiples of 1, 100 and 10,000 and so on are all called vargasthanas. The decimal places which are multiples of 10,000, 100,000 etc. are called avargasthanas. Simply put, in any given number, starting from the rightmost end, we must mark all the odd places, which is the first, third, fifth digit, etc., as V or the Vargasthana at the top, and all the even place digits, which means the second, fourth, sixth, etc., as A or Avargasthana digits. So, as you can see here on the screen, starting from the digit 5 here, we mark as Vargasthana, and subsequently Avargasthana, Vargasthana, Avargasthana and so on. This we do till we reach the leftmost digit in the number. So now we will look at Aryabhata's square root technique. The method given by Aryabhata and other Indian mathematicians can be understood in these 3 following steps. These steps are also the explanation of the Sanskrit verse we saw in the earlier slide. So step 1. Starting from the least significant digit, which is your leftmost digit in the number, group the digits of the given number into 2. Then from the remaining 1 or 2 most significant digits, which constitute the Vargasthana, subtract the square of the maximum number that is possible. In the next step, once we have done this, along with the remainder, we bring down the next digit from the avarga place. This has to be divided by twice the varga moola, that is currently in the square root line, and the quotient which has to be taken to that line. Next, along with the remainder, we bring down the next digit in the varga place and subtract from it the square of the previous quotient. Let us see how this technique can be applied using a simple example. So let's say we want to find out the square root of the number 576. the first thing we have to do is mark the Varga and Avarga sthanas respectively. So, here we see that the 6 is in the Varga sthana, 7 is Avarga sthana and 5th again is in the Varga sthanas. Now, let's begin. To start, we will subtract the largest square possible from the digits up to the first V. So, the first V in our example here is 5. So, we will be able to subtract the square of 2, which is 4, right? Once we subtract 4 from our first Vargasthana digit, our remainder is 1 and the root which we have derived so far is 2. We will write this separately because this will be very important in our final derivation. Once we have gotten the remainder, we will pull down the digit from the Avargasthana or 7 in this case, giving us 17 and divide this by twice of the root we have gotten so far. In our case, that will be twice into 2, which you have written here on the right hand side. So, by dividing 17 by 4, the answer which we get is 4. 4 into 4 is 16, which gives us a remainder 1. Now, from the final Vargasthana again, we drop down our 6, making it 16 and we subtract the square of the previous quotient. As you can see on the screen, our previous quotient here is the number 4. So, we will subtract the square of 4 from this number, which is 16, giving us 0 as an answer, and we will write this root down as 4. So, our final answer, since we have reached 0 in our calculation, the square root of 576 which we derive by this method is 24. As you can see, this is a fairly easy as well as quick method of finding roots. Now, let us take a slightly bigger number to try out this method, right? So, as you can see here, again we have written down our number and started from the right hand side to denote the Varga and Avarga sthana alternatively, beginning with the Varga. But here what we see is that the largest square possible which we can subtract from the first V. So, here one must note that the leftmost digit is an Avarga sthana, which is why we will go to the next digit and take both these digits together. So, we will start our calculation by taking the number 10 here. Now, what is the highest square possible which we can subtract from 10? It is the number 9, which is the square of the number 3. So, we subtract 9 giving us 1 and note down our root so far, which is 3. In the next step, again we bring our 6 down from the Avarga sthana and divide it by twice of the root so far. And here in this example, that will be 2 into 3. When we divide it by 2 into 3, that is 6. The answer we get is 12 with a remainder of 4. Now, if you remember from our previous step, here we have to subtract the square of the previous quotient, right? And the quotient which we see on the screen is 2, which is marked here in the pink. Again, we bring down the next digit, right? And subtract the square of 2, which is 4 from this number, giving us 38. And our root so far, because we have subtracted the square of 2, is 3 and 2, 32. Now, in the next step, we bring down 7 from the Avarga sthana here from the top and start performing our calculation. We will now divide this by 2 into 32, which is twice our root number so far, giving us 3 as a remainder. So, 64 into 6 is 384 and that gives us 3. In the final step, we bring down the 6, which is the units place, and subtract the square of the previous quotient. Now, if you will notice, the previous quotient here was 6. So, if we subtract 6 square, which is 36, 6 into 6 is 36, we get a remainder 0. And our final square root, because of this particular operation, is 326, which is our answer. I hope this makes this technique much clearer for you and helps you understand how for even very large numbers we are able to use this method. So as we have stopped here, the answer is 0 and we get our square root, which is 320. So far we have seen two examples of numbers where we have successfully derived the square roots by using this method. But sometimes when we have larger numbers, things can get tricky. So in this example, we will try to see how to take a slightly tricky number and yet apply the method correctly to get our square root. So as you can see, the first step is we write the number down and we annotate it at the top, right? We begin with our Varga Sthana, which in this case should be 2. So we subtract the largest square possible from the digits up to the first B. In this case, that will be 1 square. Now subtracting 1 from 2, the root so far which we get, always remember to write this on the right hand side separately. We'll get 1 as the remainder. Now pulling 9 down from the Avarga Sthana, we'll divide this by twice the root we have so far. So 2 into 1, right? Now let's say we put 9 as the dividend, we get 1 as the remainder. And pulling the next digit down from the Varga Sthana, here you can see we have pulled down 8, right? The next step that we must do according to the method is subtract the square of the previous quotient. So the previous quotient in our case is 9 here, as you can see. However, we are unable to subtract 81 from 18 and therefore this calculation cannot go forward. So what do we do if we get stuck with a tricky example like this? We go back and we reiterate. Now let's see how. We clearly know this is wrong. This step will not work. So let us try 8. If 9 has not worked, what if we divide and put 8 as our dividend? In which case we get 8 into 2, 16. 16 gives us 3 as a remainder. We pull 8 from the next Varga Sthana down, get 38 and subtract the question of the quotient of 8 square, which is 64. However, again we are stuck with the same problem. We cannot subtract 64 from 38 and therefore we will go back again and redo our calculation. Now we will try 7. 7 into 2, 14, which gives us 5 as the remainder, right? So as you have seen so far, what did we do? Each time we saw that the number was too big to be subtracted in the next step, we have gone back, reiterated and picked the smaller number in order to move forward. Now let us see how this further goes. We pull 8 down as we have been doing, and yes, here you can successfully see that we have been able to subtract the square of the previous quotient, which is 7 square. So from 58 we subtract 49 and the root so far which we get is 1770. 9 is our remainder. We pull down the next digit which is 9 from the Avarga Sthana and divide it by twice into our root so far. So twice into 17, which gives us 68. So 34 is the number which we will divide 99 by. 34 into 2 we get 68, 31 being our remainder. We pull the next digit down from the top, 314, and try the method again. We subtract the square of the previous quotient. As you can see, the previous quotient is 2. So we subtract 4 from this number and get 310. See, every time you divide or subtract, always remember to add to your root so far. That will be the final answer which we will subsequently build. So 310 being the remainder now, we pull down 4 again from the top and divide it by our root so far, which is 172 into 2. So twice of our root, right? And what we get is 344. So we divide 3104 by 344 and get 9 as our quotient, 8 being the remainder. And in the final step, we pull 1 down from our rightmost Varga Sthana. Hold on to your hats, you are very close to solving this question. And you will finally subtract the square of the previous quotient. Now again you can see the previous quotient here is 9. So 9 square is 81 and we have 0, which means our calculation is over. Again, like I have said, do not forget to add digits on the right hand side to derive your root. And finally the answer which we get for this very big number is 1729, which is the correct root. So the thing to remember with a tricky question like this is to often, yes, so the thing to remember here with a tricky question like this is often we will get stuck with a big number when we pull down the next digit, but we must go back, iterate and pick a smaller number. We readjust our dividend accordingly to move forward in our calculation. And now, after seeing these 3 examples, it is time for Abhyasa for all of us. So here on your screen, you can see the different numbers, and if you try these numbers out, you will master Vargamula in no time, I assure you. Please do not hesitate to go back to the video and re-look at the method if you get confused. Try all these numbers and soon you will get much faster in finding out the square root than even a calculator sometimes, right? Thank you so much for watching, and I hope you had a good time learning these different methods. Namaste.